of Public-Private Partnerships in Fusion Science. Please join me in welcoming Dr. Ryan Umstattd, Vice President for Product and Partnerships at Zap Energy, Dr. Phil Larochelle, Partner at Breakthrough Energy Ventures, and Dr. Anantha Krishnan, Senior Vice President at General Atomics. Nyah Stewart, Associate Director for Future Technology Platforms at SCSP, will moderate this discussion.
Well, good morning, everyone, and thank you all for being here. I'm super excited for this conversation as public-private partnerships, or PPPs, as you'll hear me probably say thousands of times in the next 30 minutes, are really essential to accelerating fusion commercialization. From DOE's milestone program to innovative investment models, we're seeing new frameworks emerge that could transform how we move fusion to the grid. And I'm super honored to be joined by three amazing leaders who are kind of at the forefront of this topic. But before we kind of dive deep, I want to let each of you briefly introduce yourself to the audience and kind of share what brought you to fusion. What was that moment that you realized fusion is what I need to focus my energy on? Anantha, why don't we start with you?
Good morning, folks. My name is Anantha Krishnan. I'm the Senior Vice President for the Energy Group at General Atomics. General Atomics has been working in the areas of fission and fusion for many, many decades now. Talking about myself personally, many decades ago, I graduated. My PhD was in the area of energy sciences, and I drifted far away from that field in the subsequent years. But given all the excitement that we are starting to see around fusion energy, it made sense for me to come back to the field of energy.
Phil?
Hi, Phil Larochelle, a partner at Breakthrough Energy Ventures. So we're a firm started by Bill Gates and several dozen other business leaders and institutional investors around the world. Our mission is to help bring forward technologies that can provide abundant and sustainable energy. We've got over $3 billion under management. We've got over 140 companies, and 5 of those are fusion companies. So we're invested in Commonwealth Fusion Systems, which is a tokamak, Type 1 Energy, which is a stellarator, Pacific Fusion, and Zap, that are 2 different flavors of Z-pinches. I think that's a fair description. And then Exmer Energy, that's doing ICF with lasers. And then we also have a philanthropic grant to Marathon Fusion. And of course, the one that we gave the grant to, as opposed to invested, is the one that invented how to get gold from a fusion reactor. So, that's how it goes. So in terms of my journey, I'm an experimental physicist by training. I did my PhD at CERN, working on antimatter machines. So I'm one of the few people who can tell you that your energy density sucks. But in terms of how I got into fusion, I was a total skeptic because I was just down the road from ITER, and we all know that that was, as Dennis White would say, scientifically interesting but not commercially interesting. But I really got into commercial fusion when I sat down with the team at MIT and CFS for 3 hours, and over the course of about 600 slides, they really converted me. 600
slides that's crazy, wow. Ryan, how about you?
Well, good morning, everybody. Thank you, Nyah. My name is Ryan Umstattd. I'm with Zap Energy, our VP of Product and Partnerships. By way of background, so I was a plasma physics weenie in grad school, self-professed, but I went and did 20 years active duty in the Air Force. And the cool thing with the military service is when you're a scientist or engineer, you are basically in acquisitions, right? They might let you do some early stage R&D, maybe work on applied research in a lab, but eventually you become a program manager or project manager working with the Northrops, the Lockheed Martins, things like that. So I got to do first-of-a-kind satellite, get that launched, transitioned into the hands of the blue suits who would then fly it. So that's where I kind of realized that I was addicted to first-of-a-kind technology, right? And getting things out of the lab and getting them into the hands of the people that would use them. After the Air Force, I went over to RPE and said, hey, I'd like to help you guys do cool energy tech that maybe has application on the defense side. And so they took me in, let me be their sort of defense lead for tech to market. But at the same time, they said, hey, you've got a plasma physics background. Why don't you do tech to market for fusion? So this was 2014, 2015. And so I jumped right in, was really excited to work with the team there at RPE and then the projects that they were funding across the country. Did that for a few years and then left government service and started to help out with startups. Nothing to do with fusion, but I was keeping my finger on the pulse of fusion. And I saw what Zap Energy had built in terms of its team, the investor group that they were cultivating, and I said, how can I help? And so I joined them back in 2021. It's been an exciting ride so far, and excited to be with you all here today and share Zap's perspective on public-private partnerships.
Yeah, I really like how you guys touched on how you all have a background and kind of come from different parts of the fusion ecosystem. And I think that's really important as we kind of dive in and talk about our first topic of what should a structure of a new public-private partnership look like. So I want to hear what each of you all think is the ideal division of labor in a fusion PPP. What should the government do? What should the private sector be responsible for? How does academia and national labs fit in? We'll keep the order. How about Anantha? We'll start with you.
Great. Thanks, Nyah. So if you look at how fusion has been funded in the United States, it has been funded mainly by DOE as a public program. And as a result of those investments, you have many labs like Princeton Lab, you have organizations like General Atomics, which have operated a DOE facility like D3D. And going beyond, and of course, Oak Ridge Lab, which has done great work in fusion. And then going beyond that, NNSA investments in the area of inertial fusion. But a lot of these investments have obviously focused on bringing down the scientific barriers, increasing the understanding, really providing the knowledge base that has benefited the entire community. And in many ways, these facilities, these investments by DOE continue to have a similar role going forward into the future, in the sense that if you look at the class of facilities that are operated by the government, many of them are $1 billion or more in terms of the class of facilities that they are. And these are facilities that are focused on enabling foundational breakthroughs. If you look at the private sector, the fusion companies, they are not going to have the interest or the bandwidth to be investing in these kinds of foundational facilities. And that's where the role of the government comes in, meaning how do we operate these foundational facilities. But at the same time, if you look at a facility like D3D, it has been pushing the boundaries of scientific knowledge and innovation for many decades now. But at the end of the day, even if you look back 10 years ago, D3Ds, the people who are using D3D were mainly the national labs and the universities. But today that mix has changed. Today we have a healthy mix of private sector organizations that are starting to use D3D, including many of the fusion startup companies. They're starting to do things like materials testing. They're starting to explore concepts for plasma control. They're starting to look at how to train their AI algorithms and digital engineering tools. The great thing about these kinds of investments and these kinds of facilities is they're providing data today that can help address the development of some of the technological tools that you're going to need in order to not only come up with successful designs of fusion power plants, but also operating them 24/7 in the future. So that is clearly a place where the government has a role that is not easily replicated by the private sector.
Yeah, that's a really good point. And I actually want to turn to Ryan for your thoughts on this. As a fusion company, how has the government, like DOE's milestone program, affected your technical roadmap and your ability to attract private capital as Zap moves towards commercialization?
Sure, yeah, thanks, Nyah. So Zap Energy is one of the companies in the Department of Energy's milestone-based fusion pilot plant development program. We're excited to be playing a role in this. And again, I think the best way to structure those milestones when you're working with the government is to not accept any milestones at all that aren't already on your technical development roadmap, because that just creates mixed incentives that can be a disaster for everybody. So we make sure that those milestones are already in our roadmap. But the other helpful feature for the milestone program is that it's built in a way such that these milestones can evolve and grow with they have to be able to pivot as the nature of a startup, right? You go down and investigate, you design, procure, build something, you learn from it, and now you pivot slightly to go on to the next thing. And so having milestones that can evolve over time is important. Yeah.
Yeah. And Phil, I want to come to you on this kind of point of the future of PPPs too, because Breakthrough Energy Ventures invested in fusion before the creation of the DOE milestone program. So what made fusion an attractive investment then, and how can public-private partnerships change your investment calculus moving forward?
Yeah. Well, I'm very excited to be here talking about public-private partnerships, because I think in these areas of really hard but impactful technology development, we're at a stage where the right kind of public-private partnership can really lead to a huge amount of economic growth and leadership in the world. So to go back, what are the appropriate roles for the different parties? I would say the appropriate role for government is to make the appropriate amount of investment in fusion or any other technology and to do it at the maximum efficiency for the taxpayer. I think the role for both government and private industry, which means both the capital providers and the companies themselves, is to work together to say, all right, what's the roadmap here and what has to happen for the good of the country, for the good of the companies, in a way that makes economic sense. And then I think the role for the private companies and for the private capital, speaking for myself, is to really buy into that roadmap and be willing to take the risk, to basically say to the taxpayer, for the most part, we understand that we have a lot of upside here if this works, as does the country as a whole, but if you set the milestones in conjunction with us and you can help carry some of the load for the things that are going in the right direction, then we'll take the risk to show that we can actually get there. So one comment that I want to make, which I think is super important, because the answer, the conversation we often get is, at first, it was, oh, you'll never be able to raise a lot of money for fusion, so don't even try. And then it was, oh, you raised $10 billion, you're fine.
Yeah.
It's like feast or famine in this business. But I want to talk about the appropriate level of government investment here, because I think it's pretty important, and I think it should be part of the conversation. We were all very happy when CFS raised $1.8 billion. That was amazing. But then, not too long after, the Chinese government said, hey, there's this tokamak called BEST, and we're going to fund it to $2 billion. Okay, that's an interesting number. And then, not only that, a year or so later, we heard that there was this other tokamak, and you saw it on the graph, that they were also going to fund it $2 billion. And then we were very excited when Pacific Fusion raised $900 million. But then, I just learned today, apparently there's a 50 mega amp pulse power facility going up in China. And of course, we know that there's stuff going on lasers. We'll see what they do on stellarators. I'm sure that's coming soon. So kind of the message we're getting at private capital is, hey, what you guys are doing are great, but we're ready to outspend you. Now, I think that, as Chris Wright said, we have the amazing arrow in our quiver, which is the huge efficiency of private capital. But I do think that there's an opportunity here with the right way to structure these public-private partnerships that you can win this kind of technology race, I think not only in fusion, but in other sectors where the government leveraging private capital can actually spend way less than a government that isn't properly funding private capital. So lots of thoughts on that, but long story short, the right things for a public-private partnership are in that report, but I do want to say what's been proven with NASA and SpaceX with the milestone-based cost-share program, that is an underreported story as to how important that was to SpaceX's development. We have that now for fusion, we just have to fund it.
Yeah, that's
and I want to add to that, that role for government is really as a catalyst in these things, but you can't catalyze it without the right level of excitement and commitment to it, right? The government can provide an aggressive, sustained commitment to say, we are going to achieve this goal, no matter what, come hell or high water, we're going to get there. And that signal by itself will really help us unlock private capital. And again, being in that milestone program also means that we're getting outside external government reviewers to come in and, hey, did you meet your milestone, right? So that external assessment is valuable, I think, and our commitment to then openly publish some of our science that underpins our approach. Those kinds of things go part and parcel with the sort of public-private partnership. And I think it, helps accelerate our progress.
Yeah, I think that touches on a good point about how support should and sometimes go past just investment in dollars. What do you guys think is the most critical thing outside of funding that the government can do in a PPP? Is it setting those milestones, or is it something else? Anantha?
So again, following up on a comment that was just made, the government essentially showing its commitment to the field does a lot of good things in incentivizing a number of other parties to come to the table, whether it's private investors, whether it's state and local governments. A sign from the federal government, a strong signal, really makes that happen. It also encourages the synergistic public-private partnership models that we are starting to see happen, because that is going to be important. There's a certain vision that is represented by the US government that essentially brings people to the table. It's pretty much like what happened during the Apollo mission in the 60s, when people got excited by the vision of landing on the moon and came together from all sectors to work together and make it happen. So that's another important consequence of the government. And then, of course, it's the things that the public sector does best, which is train the future workforce. Because at the end of the day, fusion power plants are going to require a workforce that doesn't currently exist. So again, government-funded facilities are going to be training lots of people. I mean, if you, again, speaking personally from the experience of seeing D3D in operation, if you look at this facility, of course, great science is being done. But if you look behind the scenes, you see all the engineering work that goes into operating this facility on a daily basis. You see all the technicians at work, making sure that the operations are supported in just the right way. So if you put all those activities together, it's not unlike what you're going to see in the future with regard to the operation of a fusion power plant. So in order to be able to train different people in all those aspects of what is finally going to make fusion energy successful is important. And that's where, again, the government has a huge and important role.
Yeah. Phil?
Well, you know, one of the most important things that the government could do was the regulatory framework, and there's just great news on that front. That is having real commercial implications. I would say that that was the most important commercial milestone of the decade, which was the regulatory regime, and that was done. So thank you to the FIA and everyone in the companies and everyone else who helped make that happen. That was not a given, and it was a good outcome. But then I actually want to emphasize something very important, which is how the government and how it talks about things can really affect how the country feels and where it puts its resources, which is not just financial, but it's the best and brightest minds, right? So think back about the space program, right? Part of it was the money, but part of it was just like, this is important. This is how we are a great nation. This is how we can matter. And so I will say what Chris Wright did up here today, that's one of the most important things that can happen, which is the government just telling the people who voted for them, this is important and we should prioritize it, both with our money, but also where we decide to spend our time and where people put their ambitions.
Yeah. Ryan, how about you?
Yeah, I agree completely in that a big part of what government can do beyond the dollars is helping with generation of that public support and the public interest. Right? A few years back, you could stop someone in the street and they probably wouldn't know what fusion is, and that's probably still true today for the most part. But the surveys that I've seen, whether it was out of the UK or here in the US, is that the more people learn about fusion, the more supportive they are of it. And that's a role that I think that the government can really help play. You know, it shouldn't just be fusion companies out there trying to convince people that fusion's great, because that's just not going to play well. But beyond that, I think one of the crucial things that shouldn't be overlooked is the last special ingredient for how do you get something like the Apollo program that puts someone on the moon, or the NASA COTS program that makes it commercial, lower, you know, the launch costs drive down. It's that personal commitment, right? It's about finding the individuals within the government that are going to carry this. And you know, in Apollo program, it was sort of the Jack Webb that did the blocking and tackling and helped bring everybody together, whether it was on Capitol Hill or within NASA or within other parts of the administration or working with the contractors. And we saw the same thing with the NASA COTS program and Alan Lindenmoyer. So again, fusion is going to need that personal commitment from the right people within government to work across all the agencies and really make this happen now.
Yeah, Ryan, I actually want to follow up because you say personal commitment. Is that one of your key lessons that you've learned participating and seeing the DOE milestone program play out? Like, what are some big takeaways that you would add to a new program or something of it that would make it more effective?
Right. Well, so as we look at, you know, what it took to stand up the milestone program as it exists today, which is just a design program, right? It's about trying to get a bunch of fusion pilot plant designs that look credible and look like they have a shot at developing a pilot plant. The next stage of that would be a pilot plant demonstration program, right? That is, first, of course, has to be extremely well resourced. But I think I want to highlight that we did a lot of things right with this current milestone program, right? It's a contract vehicle that's really flexible in terms of being able to evolve the milestones as well as the funding that's associated with it. It's right-sized when it comes to the reporting requirements because it's just about those milestones. But there's things that we could do better. And what I'd like to pose as we look towards a demonstration program is that I would love to have the government sort of prioritize their desired outcomes. What do I mean by that? Well, one thing the government could be very interested in is making sure that fusion commercializes here in the US from US companies. Another thing that government can also prioritize is we spent a lot of time in this DOE milestone program between the companies and the government working on contract clauses. Now, I get it that contract clauses are mostly written for unfortunate what-ifs, but we spent a lot of time on corner cases about intellectual property, right? Things like defining what is going to be a subject invention, what should the government license look like, are there going to be march-in rights, how do we handle proprietary information and its release. Those didn't need to actually take so long, and I think that the government can choose to prioritize bringing prosperity to everyone and maybe step back away from intellectual property, leave that in the hands of the fusion companies. That would be a strong recommendation for me on how we might approach the next program.
Yeah. Phil and Anantha, I see you guys nodding. Do you have anything you want to add or agree with? Or
Well, you know, a program so nice, I'll mention it twice. Like, read what the people at SpaceX say about the COTS program. You know, one of the few areas where you can point unambiguously to US dominance is launch vehicles to space, right? That happened through a good public-private partnership. And so, again, we have an amazing program. The scaffolding is there. It was in Chris Wright's report today that that's going to be a big part of the platform going forward. I think that the three main recommendations in there are more of them, but you know, commercially relevant R&D, we want to do that. We have to get later on in the process, which is how do you do the finance for actual power plants. But the place where we are now is the milestone program. If you fund it, I think everyone's going to be amazed by the results, and the companies are already hitting their milestones. So Chris Wright was at CFS talking about how CFS was hitting a major milestone. So again, we're talking about what could the next cost share program be. How about we fund the current one?
Good point. Anantha, anything to add?
Just to add, again, talking about the government's role in establishing foundational facilities to truly enable the successful commercialization of fusion energy, there are a few other foundational facilities that need to be established, whether you're talking about a blanket component testing facility or an advanced materials testing facility or a fuel cycle facility. These are the hard problems, the hard challenges that need to be addressed through these foundational facilities, so we can generally think of and work towards making the fusion private sector successful.
Yeah, and I think we've been talking about the public-private partnerships that will lead to fusion being commercialized, but what happens to PPPs when we get there, right? Fusion's going to eventually go to higher TRL levels. So how, in your mind, do these public-private partnerships change when fusion does become a commercial technology? What's the long-term role of government when fusion is actually delivering electricity to the grid? Ryan, yeah, you want to start?
Spreading prosperity, right? I mean, that's what this is all about. It's not about the race to the first fusion power plant on the grid. It's about how do you get the first fleet of fusion power plants on the grid. That's what's going to change the world. And I think that in that environment, the government's role will be in spreading prosperity to all corners of the US and the earth. You know, from a company perspective, look, I've got to be responsible for generating a profit and generating a return for our investors. And so that altruistic goal of spreading prosperity, it's just takes a lower level. It's not at the top for a corporate.
Yeah.
And so I think that's how the nature of the roles evolve when we're at a stage where fusion is commercial, is that the government's still going to need to be there to make sure it gets everywhere and everybody benefits from it. And we've still got to, you know, run a viable business.
Yeah, Phil?
Well, you talked about what government should do to support it once fusion electrons are on the grid and ubiquitous. Well, we got a ways to go before there. So look, other than the significant technological challenges that we should be open about, there are three big funding things that have to happen, right? One is equity for the companies. That's how they actually retire the technology risk and build their stuff. Then there's project finance, and then there's offtake. And so the government has mechanisms to do a lot of that. I think they need to turn it now towards fusion and say, how can we best leverage taxpayer money together with private industry, which not only means, you know, the vulture capitalists like me, but also the later stages of capital. How can we collaborate with the hyperscalers who are really leaning in? And then project finance, you know, things like loan guarantees, I know have had sometimes good results, sometimes not so much. It doesn't mean that it's not something you have to figure out how to do. So I would say those three buckets. corporate equity and doing that stuff. You can help a lot with the cost share program. Project finance, let's think about new ways to do it, but the government has been involved in the past. It could be involved in the future. And then for offtake, perhaps there's a role for government to do in the early stuff in terms of procuring fusion power, maybe, matching one for one with other folks. I think that there's a lot of innovative things we should do, but we should really bucket in those three big challenges. And the great news is that we actually now have to start worrying about project finance and offtake. I mean, we've had 2 governors announcing power plants from fusion companies. This is great news, but now is the time to put some more resources behind it.
Fair, nothing.
I think when you have the first fusion power plants operating, they are certainly not going to be the most efficient or the most optimized power plants. Certainly the cost of fusion energy is not going to be where we want it to be. So there's going to be more work that needs to be done in coming up with the optimization of these plants, coming up with new materials that lower costs, coming up with new processes. And if you look at the field of fusion today, again, we talked about it this morning, where there are multiple approaches. The first approach that becomes successful may not be the approach that will be used 50 years or 100 years down the road. So figuring out how to explore the other ideas, the other fusion technologies, the concepts. Again, that's the role of government, trying to make sure that we build better fusion, more efficient fusion plants in the future, reduce the cost of fusion energy, making it more and more affordable. Those are the kinds of things government is good at doing.
Yeah, and I think there's a couple of other tools that we haven't talked about yet in the government's tool belt for how they can do that. Because look, any new energy technology, electricity particularly, when you're trying to enter into a commodities market, you've got that challenge, right? Brand new tech, commodities market. How do you compete at cents per kilowatt hour or dollars a gallon? Well, the government has some tools there, right? Phil mentioned the licensing piece in terms of the regulatory. That was fantastic. But there's more work that can be done there. Like in the state of Washington, they're providing not just right-sized and clear regulatory guidance, but optionality, right? In the state of Washington, if I want to site my fusion energy facility, I can go through the local community process, show up at the county commissioner's board and try to get my permits that way. But you can also choose to engage at the state level. They have an energy facility site evaluation council that takes different pockets from within Washington state government and will help coordinate the processing of the permit and the siting applications. So that optionality is helpful. And then last, of course, can't get off the stage without talking about tax credits, right? Because that's another great way for new technology to enter into a commodities market, is whether it's through an investment tax credit or a production tax credit. Those, I think, are going to be absolutely crucial for commercialization of fusion and scaling up and getting these plants out there as fast as we can.
Yeah, and I think that's a great place to end about how we have so much work to do, but so many tools in our toolbox. Please, everyone, join me in thanking our panelists today. It's been a great conversation. Thank you.